Okay, so we have completed the NumPy library, right? Now let's move on to the next library, which is Pandas. Pandas stands for panel data and is the core library for data manipulation and data analysis. Pandas basically gives you single and multi-dimensional data structures. Okay, you can create single dimensional as well as multi-dimensional, okay, structures, and you can perform various types of data manipulation operations on these single and multi-dimensional data structures. Single dimensional data structure in Pandas is known as the series object, and the multi-dimensional object is the data frame. Okay, remember that single dimensional data structure in Pandas is known as the series object, and the multi-dimensional object is the data frame, right? So first we will understand Pandas series object. So let's start off with the first one, which is the series object, and first we have to import the library. And to import the library, okay, type in here import pandas as pd. So this import is the keyword, and the pandas is the name of the library, and then uh, we are giving this an alias. By convention we give an alias of pd. Now create a series object. Okay, run this cell to import this and then create a series object, which is basically a one dimensional object. Okay, we can use an inbuilt data type series, okay, to create a series object, and for that we will be using a list. So let's first create a list. L1 equals to, okay, create a list, use square brackets 1 comma 2 4 and 5. Run this cell. So we have created a list L1, and this list 1 is comprised of 5 elements 1 2 3 4 and 5. Now create a new series. So S1 equals to, use pd, this alias, this name, pd dot series. So this series is a class, and here pass L1. So we are passing L1 list to series. Pass this list to the constructor of the class, run the cell, and then print S1, and see we have 1 2 3 4 5 elements. Okay, and every element has an index associated with it, right? Because it's a series. So this is what we get. We get what? We get a series. Now check the type of the object. So to check the type of this S1, you can use type function and pass the object name whose type you want to check. We want to check the data type of S1. Run the cell, and this is the type. Okay, this is of type pandas dot core dot series dot series. So this is series type. So we have successfully created a series object from a list. Okay, so these are the elements, okay, which are present in the series object 1 2 3 4 5, and on the left side what you see are the indexes, right? 0 1 2 3 4, these are the indexes. So for value 1 index is 0, for value 2 index is 1, for value 5 index is 4, right? So remember that the indexing starts at 0. It always starts from 0, right? Now let's say we want to create some other series object, and so let's do the same thing. What we can do is here, let's copy this, paste, object name is s2, and we can create a list here itself. So let's so we will pass in some random values. Okay, 15, 10, 53, 22, and 588. Any random values, right? So we are passing 5 random values. Run the cell. Now print s2 and see. So we have the 5 elements here: 15, 10, 53, 22, 588, and these are the corresponding indexes: 0, 1, 2, 3, 4, 5. Okay, these are the indexes. Now let's see how we can change the index of the elements. Okay, let's create a new series object. So let's create s3, copy this, create s3, and 1, 2, 3, 4, and 5. Okay, so we are creating third series s3. So we have created s3 object. Okay, a new series object. Now let's print s3, and it is 1, 2, 3, 4, 5. Okay, now to assign indexes. So actually we have created a new series here. Now let's say instead of the index to be comprising of these numerical values, currently by default actually index is always numerical value. We want them to be alphabets, right? So all we have to do is use the index attribute inside the series constructor, and then we can give in the corresponding index values. So by default you will get what? You will get 0, 1, 2, 3, 4, 5. Okay, indexes. You will get all of the index values in ascending order of numbers. Okay, these are the ascending values. So instead of that, I want to assign the index values to be suppose A, B, C, D, and E. Okay, so to do that, what we can do is here we can use index attribute, index, and within square brackets, okay, we can specify the values for indices. So suppose for first value, okay, we want A, for second value we want B, third value we want C, fourth value we want D, and we have 5 values. Okay, fifth value we want E. So here we are specifying indexes, okay, for these values. By default it is 0, 1, 2, 3, 4, 5. Okay, numeric values. Now we want A, B, C, D, E, okay, to be indexes. Run this cell and run this cell, okay, to print out s3. And now if you see, value 1 index is A, value 2 index is B, okay, value 5 index is E, right? Here first element is A, an index list. So this A will become index, okay, for first element, okay, in the list, in the series. B, the second element, will become index for 2, and E will become index for 5. Okay, so now indexes are A, B, C, D, E, right? So here we have successfully changed the index values from numbers, okay, to these alphabets A, B, C, D, and E. So we can give any random index values here. It could be anything. Okay, what we can do is let's copy this, paste. Okay, and I said it could be anything, so let's use here code for second value 2 and camp for third value. Okay, now here we have a code camp de, okay, for these values. Run this cell and now print s3 and see, now we have index for 1 is a, index for 2 is code, index for 3 is camp, index for 4 is d, and index for 5 is e. Okay, the value is 5 and index is e, right? So as you see here, okay, we can use any random value, okay, for index, right? So here we are using code camp for second and third values. So these are the index values now, right? Now we'll discuss how to create series object from dictionary. Okay, here we are creating series object from list. Okay, in everywhere we are creating this list, we are creating it from list, right? We are creating from list. Now we will discuss how to create series object from dictionary. So instead of passing a list, okay, we can just pass in a dictionary. So let's create a dictionary first, and for dictionary we always use curly braces. So first key is a and value is 10, second key is b, value is 20, third key is c and value is 30, and let's create one more key value pair. Okay, key is d and value is 40. Okay, so here we are creating a dictionary. So we have created x. Let's print out x, and x is a dictionary. Okay, you can check the type of x, and it is dict. It's a dictionary, right? Now we will create a new series object from this dictionary. So s4 object and pd dot series and pass x. Okay, run this cell. Now print out s4 and now see value 10, this value 10, and its index is a. So all keys a, b, c, d, okay, all keys are used as indexes and values are used as values, right? So here value is 10, key is a, value is 10, and index is a. Value is 40, key is d, and here this value is 40 and index is d, right? So here we have created a series object from the dictionary x, and now that we see here is all of the key values, they have been used as indexes, right? So a, b, c and d are the keys which have been taken as indexes here. Okay, so for the value 10 index is a, and for the value 20 index is b. If you want to change the order, the sequence of indices, okay, now let's see how can we change the index position of the series object. So here let's create a new object, or let's try to create, okay, let's create this object again here in this new cell. So s4 equals to pd dot series pass x, the dictionary, and then you can use index attribute, okay, to specify the index, right? So suppose here in this output 40 is the last element, because this 40 is the last element in the dictionary, Okay, so 40 is the last element in this series. Suppose we want this last element to be first in this series. What you can do is you can pass the key of that value first, okay, in this list, index equals to, right? Now this is first in this list. We want second element, okay, B to be second element, C to be next element, and A to be the last element, okay, in the list. So we have these keys. We have A, B, C, D, A, B, C, D keys. Okay, now we want these values to be added to this series. Okay, we want this series to be created, okay, based on these values, okay, based on this order, right? Run the cell and print out S4. And if you see here, D is the first element, value is 40, this value is 40. Now earlier it was last element because this is last element in this dictionary, but now it is first element in this series. Its index is D, okay, because we supplied this D as a first element, okay, in this list. Next element is, next value is 20, index is B because we passed B as second element. Okay, last element value is 10, index is A because we passed this A as last element, okay, in this list. Okay, so this is how you can change the position of indices, right? Position of index. Let's add one more index and see what happens. So if you add one more index here, right? So let's add EE. This D, which is first element in this index, for this D, okay, we have value here 40. For B, we have value here 20. For C, we have value 30, okay, in this dictionary. For A, we have 10. EE, we don't have this key here in this dictionary, right? So in this case, run this cell, run this cell again, and if you see here, if you use a key, an index list for which a value is not present in the dictionary, we are using X dictionary here. If for this key, if this key is not present in the dictionary, in that case, okay, the value will be NaN. So now we have this key here, okay, this as index. So E is index, but value for this index is NaN because the value for this key is not present in this dictionary, right? So if you add a key to this index list for which a value is not available, or the for which the key is not available, corresponding key is not available in the dictionary, then you will get NaN for that particular index in the series object, right? So this is NaN means value is missing, okay, value is not present. So if we add a new index and if we don't have corresponding key mentioned in the dictionary, okay, then we will just have a NaN value in the series of object, okay, which we created. So as we see, we have A, B, C and D in the dictionary, which are the keys here, okay, B, D, B, C, A, these are the keys here, and then we have the corresponding values associated with these key values 40, 20, 30, 10. We have, okay, these values. So this 10 is for A, 20 is for B, and this 30 is for C, to 40 is for D, right? So but the problem is we have also created a new index here which is EE, and we don't have any value associated with this key. So that is why we have NaN here, right? This is NaN. Now we will discuss extracting elements from a series object, right? So now let's see how can we extract individual elements and series of elements from a series object. Okay, create a new series object. So let's create as 5 equals to pd dot series, and here let's create a new list first, and based on that list, okay, we will create this object. So L2 list 2 equals to 1 2 3 4 5 6 7 8 9 and 10. Okay, and then S5 equals to pd dot series pass L2. Okay, run this cell. Okay, so we have executed this cell. Now print out S5, and S5 is, now see, 1 2 3 4 5 6 7 8 9 10. These are the values and these are the indexes. Okay, 0 through 9, these are the indexes. So now it is time, okay, to extract the elements. So to extract an individual element, so from this list, from this series, if you want to extract 4, this element, okay, so its index is 3. Here you can write S5 of 3. Run this cell and see, we get 4. Okay, so 4 is the value, its index is 3, so S5 of 3, okay, would give you 4, right? If we want to extract a sequence of elements, okay, to extract a sequence of elements, or use a column. So here, suppose we want to extract, okay, first 4 elements, 1 2 3 4, first 4 elements, okay, 1 2 3 4, first 4 elements. So here what we can do is, we can write S5 use colon. Here before colon, on the left side of colon, you can specify the starting index. If you don't specify starting index, it means the beginning. Okay, that indicates what? The beginning. So we are not specifying the starting index here. So if you don't specify the starting index here, it means the beginning 0 index 4. Okay, because we want to extract 1 2 3 4. So this 4 is not this value actually. Okay, this is not this value. Okay, this 4 is this index. Okay, a number actually, right? So here if you run this cell, so now we are getting what? First 4 elements, 1 2 3 4, right? So from the beginning, because we did not specify any number, any index on the left side of this column, it means from the beginning, from the start, and on the right side we have 4, and this 4 is, so starting from 0 index, it will go till index 4. Okay, till this index, right? Here this 4, this upper index is exclusive. Exclusive means, so it will not be used actually, so it will go from 0 to 3, right? So it is exclusive. Okay, if you want to extract elements from the back, suppose you want to extract, okay, 10 9 8 7 6. So suppose you want to extract, okay, these elements 6 7 8 9 10, right, starting from 6 till the last element. In that case what you can do is, okay, you can use the minus operator. Okay, we would have to use the minus operator in that case, okay, to extract, okay, elements from the back. So here if you want to extract last three elements, suppose, so to extract last three elements of S5, this is S5 minus 3, it means now start from the beginning, or from the end actually, from the back. So minus 3 means this is minus 1, minus 2, minus 3. So starting from this, all the elements. Okay, so minus 3 column. Now we are not specifying any number on the right side of this column. It means starting from minus 3, all the elements, okay, till the last element. Run this cell and see, this is 3 elements from the back. So 8, 9 and 10. So we are getting 8, 9, 10 here, right? So minus 3 means we are specifying the starting position from the back, but we are not specifying the last index. Last index means up to which position or the index, okay, it should extract, okay, numbers or sequence. Okay, we are not specifying that. So if we don't specify that, it means all the values, okay, starting from that position or that index, right? So if you want to extract last 5 elements, you can write S5 within square braces, okay, you can write minus 5 and then colon, okay, don't forget to use colon. So here if you don't specify any number here after the colon on the right side of the colon, it means you want to extract all the elements starting from this specified position, right? Run this cell and now we get what? 6, 7, 8, 9, 10, 5 elements from the back, right? Now we'll discuss basic math operations, okay, which we can perform on series. So now let's see how we can add a scalar value, okay, to a series object. So all we have to do is we have to use the plus operator. Okay, here suppose you want to add a scalar value to this. Let's print S5 first. Print out S5. So this is S5, okay, for our reference actually. So this is S5. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the values. Okay. So here we want to add 5, okay, to every element in this series. So we can write S5 plus 5. So this 5 is a scalar value. Okay, it is scalar. So S5 plus 5, it means 5 will be added to every element, okay, in the series. Run this cell and see. So we have 1 in this series. So now 5 plus 1 is 6. We get 6. We get 2 plus 5 is 7, 3 plus 5 is 8, 4 plus 5 is 9 and so on. And last element is 10, 10 plus 5 is 15. So this is how, okay, we can add a scalar value to a series. Okay. Next, okay, to subtract a value or scalar value. Okay, suppose you have requirement to subtract, okay, 2, okay, from a series. So here we can write S5 minus 2. Okay, we want to subtract 2 scalar value from S5. So from every element of S5, okay, 2 will be subtracted. Run this cell and now we have first element is 1. So 1 minus 2 is minus 1. Second element is 2. 2 minus 2 is 0. Okay, 3. 3 minus 2 is 1. And last element is 10. 10 minus 2 is 8. So this is how you can subtract a scalar value, okay, from all the elements of a series. Similarly, to multiply it with the scalar value, so suppose we want to multiply this series with some scalar value. So let's say 2. Okay, we want to multiply it with 2. Run this cell and now we have, this is 1 into 2, 1 cross 2 is 2, 2 cross 2 is 4, 3 cross 2 is 6, and the last element is 10. 10 cross 2 is 20. Okay, so this is how we can use some basic operators, okay, with a series object. Okay, we can perform addition, subtraction, multiplication, okay, any operation, any basic operation that you want to perform. Now let's see how we can add two series objects. Okay, suppose you have requirement to add two series objects. So let's create another series object, okay, with some number of elements as the series S5. So use we this is S5. So let's create S6. S6 equals to, okay. So let's create PD dot series, and here let's pass 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Right? Let's add a new cell here and run print out S5 for reference. So this is S5, and S5 we have 10 elements, index 0 through 9, and here we are creating a new series with same number of elements. Okay, 1 2 3 4 5 6 7 8 9 10, same number of elements. Run this cell. So we have created one more series, S6. Okay, we have S5, we have also created S6, and S5 has 10 elements, S6 also has, okay, 10 elements. Now to add two series, okay, what you can do is you can write S5 plus S6. Okay, here we are going to add two series. So you can use plus operator, run this cell and see. So this is, if you see, 1, S5 is 1, in S5 the value at first index means 0 index, first position is 1. Here value at 0 index is 10, so 10 plus 1 is 11, so here the value is 11. Okay, 20 plus 2 is 22, so value is 22. Okay, so here elements at corresponding indexes, okay, have been added, and last element is 100. Here last element is 10, means the value at index 9 is 10, so 100 plus 10 is 110, and we have 110 at index 9, right? And similarly you can perform subtraction. So S6 minus S5, run this cell, and if you see here, so 10 minus 1 is 9, 20 minus 2 is 18, and 30 minus 3 is 27, last element. 100 minus 10 is 90, right? So this is how you can perform subtraction, right? You can subtract one series from another. Okay, so now we'll discuss, suppose we have a list. Okay, if suppose we have a list and which has more number of elements, so let's create a new list. Okay, name it as 7, and let's add one or two more elements, 110 and 120. Now in S5 we have 10 elements. Let's print out S7. In S7 we have 12 elements, index 0 through 11. Okay, 12 elements. Now if you want to perform S5 plus S7, okay, S7 has two extra elements, S5 has 10 elements, S7 has 12 elements. And see, now 0 through 9, okay, we have numbers, but for 10th index, 11th index, okay, we have NaN. So NaN plus a number gives you NaN. Let's print S5. Print out S5. If you see here, last index is 9. Here last and this index is 9. So till 9 we have values, right? We don't have any value at index 10 and 11. Okay. So here in S7 we have two extra elements. So for index 10, for which we don't have value here in S5, okay, we are getting NaN, right? And for index 11, we don't have value here in S5, so again we are getting NaN. So NaN plus a number is always a NaN, right? So that's all for this session. We'll continue this pandas in next session. In next session, today we covered series actually. In next session, we will cover data frame, multi-dimensional uh, structure, okay, which is known as data frame. So we will cover data frame also. So that's all for this session. Thank you everyone for joining today's session. Thank you.